live. Testing. 1, 2, 3, 4. So here's the problem that we're starting off the day with. Would you take this deal?
Yes.
Okay?
Yes.
We'll
yes.
see.
Trust me, you would.
We'll see in a minute. So Mitch says yes, definitely. We'll see. So this chapter is called 8-3, I think. Geometric sequences. Geometric sequences. And the first a geometric sequence is, okay, one that looks like this. 3, 6, 12, 24. What comes next? What comes next? 48. What am I doing to get the next number in the sequence? Doubling, okay? That number, so a geometric sequence is one where you multiply, okay? One where you multiply each subsequent term, each term by a constant, or divide, okay, to get the next. To get the next. Okay? And we call that constant as name, and it's called the common ratio. Common ratio, and they call that, it has a letter, and it's called R. Okay? Hello. So, in this case, R is equal to what? What's R equal to? What am I multiplying to get the next term? 2. Okay? 2. Okay? And a way you can define this recursively, recursive definition of a geometric sequence is you have a sub 1, and then you have a sub n is equal to a sub 1 times r raised to the, this is not, sorry, I messed up. A sub k, I was thinking of the explicit definition, okay? A sub k is equal to a sub k minus 1 times r, okay? So in other words, to find the next term in a geometric sequence, you take the previous term and you multiply it by r. This leads to the idea that r is equal to a sub k divided by a sub k minus 1. I think in the book they call that variable n. They call that n? Yeah, they call it n. Okay? But it's okay. So in other words, to find the common ratio, you divide this term by this term. So for example, what if I had this sequence, let's see, 1, 3, 9, 27, 81. What's R?
3.
R equals? 3. And to find that, you divide any two terms by the previous term. If they tell you it's geometric, then you just have to do a 1. So 27 divided by 9, right, using this formula, is equal to 3. Or I could have gone 81 divided by 27, right, is equal to 3. Because the opposite of multiplying is dividing, right? Or I could have got 3 divided by 1 is equal to 3. Sometimes they'll say, is this sequence geometric, Michael? Is this sequence geometric? And if you divide and you don't get the same thing each time, then it's not geometric, right? So what if I have one that looks like this? 1/2, comma, 1/4, comma, 1/8, comma, 1/16. Is that geometric?
Yes.
How would I find out who knows what the common ratio is? You're multiplying by 1/2. If you did not know that, you can divide any two terms. So if I divide 1/8 by 1/4, okay, I can copy that flip. So I would get 1/8 times 4 over 1, which is equal to 4/8, which is equal to 1/2, right? That's R. Yeah? Okay. You want to take a nap now, Evan? You too, Francesco? A little bit? Okay. Get that, Dee? Okay. Explicit formula. Explicit is one. No, I said that already. Were you? Explicit formula looks like A sub n. This is easier. A sub n is equal to A sub 1 times R raised to the n minus 1 power. Okay? And so, for instance, in this case, right, if I want to find like the fourth term of this sequence, right, I would just take the first term, which is 1, and I raise it. So if I want to find A sub 4 for this sequence up here, right, I know that A sub 1 is 1, R is equal to 3, and I would raise that to the 4 minus 1 power. So A sub 4, the fourth term, is going to be 1 times, you don't even need the 1, right, because 1 times anything is just 3 to the third. What's 3 to the third? 27. Okay, and there's the fourth term right there, right? Yes? And it's n minus 1 because when I plug in n minus 1 in here, when I plug in 1 in here, what do I get out? I get out the first term, right? Because if I plug in 1 in here, I get 3 to the 0. What's 3 to the 0, Cassie?
1.
What's 3 to the 0? 1, right? And 1 times 1 is 1, which gives me the first term, right? That's why when you raise it to the, that's why it's n minus 1 and not just n. But sometimes it ends up being n. We'll see a couple examples like that. Okay? Questions? Okay then, we're going to go on to the sum. I'm kind of skimming over a couple things, but I think you guys want me to do that. Find the 15th term. Find the 15th term of a geometric sequence if A sub 3 equals 5/4 and A sub 6 equals 5 over 32. Okay? So this is a lot like those problems that we did over there where you're given two terms in your sequence and you have to solve an equation with two variables. So first thing, you say that A sub 3, which is equal to 5/4, is equal to A sub 1, which I don't know, times R raised to the third term. What is going to go up here? 3 minus 1 power. You guys get that, right? Because it's n minus 1. And then I also have that A sub 6, which is equal to 5/32, that's going to be equal to A sub 1, which I still don't know, times R, which I still don't know, times, that's a 6 term, 6 minus 1. So now what I have is this system of equations right here that I need to solve. Anyone have any idea how to solve that system? There's an easy way. How could I get rid of those A's? not subtract. You could substitute and then subtract, but it's kind of like the easier way. Anyone? Yeah. Divide. Okay? You divide. So I'm going to put this term on the top, so I'm going to say that 5/32 equals a sub 1 times r to the 5th. Everyone with me there? Okay? And on the down below it, I'm going to put 5/4 equals a sub 1 times r to the 3 minus, which is 2. And I'm allowed to, since those equations are both equal to each other, I can divide both sides like that. I'm allowed to do that. Did you know that? I can divide both sides. I can divide an equation by something else that's equal to itself. What happens to my a sub 1s? When I divide, boom, right? What's r to the 5th divided by r to the 2? Subtract the exponents, what do you get? R to the 3. So you get r3 equals this divided by this. And you go, I don't know how to divide 5/32 divided by 5/4. Well, we'll do it. 5/32, you flip this over, 4 over 5. What happens to the 5s? They cancel. And you get 4 over 32, which is equal to 1 over 8. So r cubed is 1/8. That means that r is the cube root of 1/8. What's the cube root of 1/8? 1/2. Okay? So that's your common ratio. Questions? Am I going too fast? Am I going too slow? Okay. So now I know r. I still need to find a. So you need to plug into one of the equations. I would take the simpler of the two and plug in my r into there, okay, and see what I get for a. So I get 5/4 equals a sub 1 1/2 squared, okay, and that gives me 5/4 equals a sub 1 times 1/4. So just by looking at it, can anyone tell me what a sub 1 is? 5, right? Because you could divide 5/4 by 1/4, you get 5, or you could just say, well, if I multiply this by 5, I get 5/4, right? And so therefore, my equation is, look at these nice colors I'm using, a sub n is equal to a sub 1, which is 5, times r, which we found out is 1/2, times raised to the n minus 1 power. Okay? And then I want to find the 15th term, so I'm going to plug in a 15 in there. Okay? 15. And this is kind of in parentheses. And that's 5 times 1 over 2 raised to the 14th power, which as a fraction, it's 5 over 16,384. I just did that in my head. I didn't really. I just knew it. Okay? We're not done yet. You need a break yet? You want to stand up and spin around a couple times? You want to sing songs? You want to hear a joke? You don't want to hear a joke? I'm going to tell you one anyway. Did you hear about the fly that went into the cow's ear? No? It went in one ear and out the other. You get it, Francesco? Oh. Udder, that's the thing that comes out of cows. You know those things where they milk the cow from? That's disgusting. In one ear and out the other. You get it? Yes? Yeah, okay. What do you think? Scale 1 to 10. The better? Which was the better? Oh, the fan?
Yeah.
Oh.
You should use that.
You didn't hear my fan joke, did you? They asked me if I could turn on my fan. I said, well, maybe if I whisper sweet nothings into its ears, it would be turned on. Anyway, moving on. Rolling. So this is where we have fun. The The next thing is the sum. Sum of a finite means it ends, okay? Geometric sequence, also known as the sum of a sequence is also known as a series, okay? Geometric series, okay? I would derive the formula for you, but I will just let those people look it up in the book if they're interested. But you end up with this formula. S sub n is equal to a sub 1 minus a, whoops, I didn't simplify it, hold on. Is equal to a sub 1 times 1 minus r raised to the n over 1 minus r, okay? How does that work? They say evaluate, and here it'd probably be better to know how to do this with the formula than with a calculator. N equals 1, 2, let's just go, let's make this 5, okay? 2 times 0.1 raised to the n minus 1, okay? So say I want to evaluate this geometric series, okay? So you're summing up, what would be the first term in this series? 2, right? What would be the next term? If I plug in 2 in here, I get out 1. What's 2 times 0.1? It would be 0.2, right? 0.2 or just 0.2, right? What would be the next term? 0.0. No, what would it be? You'd multiply this by, I just made this one up. So the next term would be the third term. You'd take this, which is 0.01, right? 0.01 times 2, so you'd be adding another 0.02, right? Okay? Hello? Okay? And I'm making this one relatively easy. So I get plus, you would add a 0.002, right? And then you'd add a 0.0002, right? Which altogether you'd have 2.2222, which is close to 2/9, which we'll get to in a second, right? Okay? But using the formula up here, because sometimes it won't be as neat as this, using the formula, you can plug in S sub n is equal to a sub 1, which is 2, 1 minus, what's r in this case? What am I multiplying by each time? 0.1, okay? 0.1, you have to kind of put this in parentheses and then raise it to the n minus 1 power, which would be 4, yes? And then you would have to divide that by 1 minus 0.1, which if you do the math comes out to be 2 times 1 minus 0.1 to the fourth is 0.00, what is it? 0.0100, what's 0.1 to the fourth? 0.001? Is it 0.00? 3 zeros? 2 zeros? 0.1.
It's 2 zeros.
3 zeros or 2 zeros? Wait, the first power is going to be 0.1, second power is going to be 0.01, third power is going to be 0.001, so the fourth power would be 0.001, right? Yes? Okay? Divided by 1 minus 0.9 is 1 minus 0.1 is?
But why to the fourth?
What?
Shouldn't you take this?
Because
Shouldn't it be 2 0?
Because, oh, sorry. Because I was doing n minus 1, I should have done n, right? That should have been 5, right?
Yeah.
So that should be 0.0001, right? Am I right, Francesco?
Yes.
0.0001, right? Tell me I'm right. This is what happens when I make up problems as I go. 0.9, and that is 2 times 1 minus 0.000001, which is 1 minus, which is 0.99, another 9 divided by 0.9, right? Yes?
Maybe one more nine. Yeah, probably.
There'll be one more 9. There you go, 5 9. And so if you did that, you could actually multiply everything by 10. If I did multiply everything by 10, I get 2 divided by 9 times 9.9999, which gives me, what does that give me?
20.
It'd be really close to 20, right?
20 over 9.
It'd be really close to 20 over 9, right? Wouldn't it be?
No, I mean, you
What?
said 2 over 9, and you're multiplying by 10, right?
Yeah. Yeah, but I just moved this decimal place.
Oh.
And I moved this decimal place. So that's really close to 22. That's really close to 2.2, right? 2.2222, which is what I got over here, okay?
It's that result.
What?
Yes, that's the result.
That's the result.
It's not close to it. It's that.
That is the result, yes, okay? Oh, it is exactly the result, you're right, okay? So, 2.2222. So it seems like, why not just do it this way and add up those terms? Because if you did only have 5 terms, that's pretty easy. But if you have 100 terms, then it gets more complicated. Yes? So you don't want to add up 100 things because it would be a pain in the neck. But what's cool, okay, about this is where it gets kind of fun, okay? What if, no really, I know you don't think it's fun, but what if I take this thing here, okay? Place, capture, duplicate. So I'm going to grab this formula here, okay? And I want to add up infinitely many terms. So instead of this being S sub n, I change this to, I want to add up infinite terms, a sub 1 times 1 minus r raised to the infinity, okay, over 1 minus r, okay? If r is a number that's less than 1 and greater than or equal to -1. So in other words, if this is a fraction, okay, less than 1, or greater, it could be a positive fraction or a negative fraction, doesn't matter. So, because I'm going to be subtracting it anyway. But if this is a fraction, so what happens if I take 1/2 and I raise it to the 20th power? What kind of number do I get? A very, very, very small number, right? So if I take 1/2 and I raise it to this, so what happens if this is a fraction? This thing turns into what? What's a very small number when I go to infinity? Right, 0, right? So what happens is the sum of an infinite sequence where that number is a number that's between -1 and 1. Another way to write that is that the absolute value of r is less than 1. S sub infinity is equal to a sub 1 over 1 minus r. In other words, if all you have to do is know the first term and divide by 1 minus the common ratio. Okay? So this is the formula for the sum of a converging meaning it reaches a value where r is less than converging infinite series, okay? Geometric series. Geometric series. That's what happens when I don't put that in. Okay? The sum of a converging geometric infinite series. Okay? So if I have something like this, 1 plus 1/2 plus 1/4 plus 1/8, what do you think the sum's going to be? So dot, 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 dot. Sum of this. Not 1, 2, right? What's a sub 1 in this case?
1.
A sub 1 is going to be 1. What's r in this case? What's r? 1/2, right? So 1 minus 1/2. What's 1 minus 1/2? What's 1 minus 1/2? 1 minus 1/2 is 1/2. What's 1 divided by 1/2? 2. See? So if I add up all these numbers, 1 plus 1/2 plus 1/4 plus 1/8 plus blah, 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 I get to 2. Isn't that amazing? Well, look. Suppose, I kind of showed you this the other day, but suppose that this has an area of 2. This box has an area of 2. Area equals 2. I'm going to shade 1, right? Then I'm going to shade 1/2. Then I'm going to shade 1/4. Then I'm going to shade 1/8. Then I'm going to shade 1/16. Then I'm going to shade 1/32. Then I'm going to shade 1/64. Then I'm going to shade 1/28. Then I'm going to shade 1/256. Eventually, how much of that box is going to be shaded in? 2. All of it. 2. Right? You kind of see that? Okay. Do we need to take a break? No. Some of you need to bring this back up. Okay? We're going to unpause. So a ball is dropped. I had a ball. Where'd that ball go? Let me find it. Where? Oh, thank you. We're having a ball in here, aren't we? So watch. Look. I dropped this ball. Boom, 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 boom. And if I dropped it from a height of 10 feet, and this, by the way, is 10 feet, because I'm like 7 feet tall, right? So it's not, just pretend that this is 10 feet. And it bounces 0.65 times as high each time it bounces. What they want to know is how far will that ball travel in its total bouncing history. Do you think that's is that a number, or does it keep bouncing forever, never, 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 never? It kind of looks like it keeps bouncing, but it doesn't. It will eventually stop because of energy and all that kind of stuff. But there is, even if it kept bouncing forever, it would still bounce a specific height. And the way that you could find that is when I drop it the first time, how far does it fall? It falls 10 feet, right? So I'm going to say it's kind of tricky, because the first time it falls 10 feet. So you have to start with 10, okay? But then you're going to sum up something, okay? So after it falls 10 feet, how high is it going to bounce? It's going to bounce 6.5 feet, but then how much is it going to fall? It's going to fall 6.5 feet again. You see that? So what you want to do is going to bounce up 6.5 feet, but then it's going to fall down 6.5 feet. Then it's going to bounce 0.65 times 6.5 feet, right? And then it's going to fall 0.65. So what you have to do after, it doesn't bounce, it doesn't do 10 twice, but it does everything else twice. You see that? And it's going to go from n equals 1 to infinity of 10 times 6.5 raised to the n power. Do you guys see that? Hello? No?
6.5 or 0?
I mean 0.65, sorry. 0.65. okay? 0.65. 0.65 raised to the infinity power, which is just, so what you have is 10 plus a sub 1 2 times the formula for the sum of an infinite series. Yes?
But shouldn't it be like n 0.65 to the n minus 1?
No, because if I put in n minus 1 here, I would get my first height as being 10, which I don't want it to be.
But then I just put an n.
What?
And then shouldn't I put n? Or infinity?
Yeah, I should put n here.
Oh,
Here? Where? Here. Right? Yeah, here.
here's a question.
Oh, that's your question. It
Yeah.
should just be n. Yeah.
Okay.
But when I plug in infinity, so.
Yeah.
So, in any case, you have an n up here. So then a sub 1, what's a sub 1 in this case? What would be my first term? What's 10 times 0.65? It's 6.5. That's a sub 1, right? Over 1 minus r. What's r in this case? What's r? What am I multiplying by each time? 0.65, right? If I do that on my calculator, which you can do, comes out to be 0.35, you get approximately 47.1 feet, right? So you understand why I have to start with 10, and then, because you're not really multiplying by anything the first time, and so you start with 10, and then you're 2 times this infinite series right there. Yes? So you get about 47.1 feet that this ball will, I don't know if it's this ball. Maybe if it was on a harder surface. Oh. Whoa! I know. We have to try a harder surface, right? There we go. Okay. Oh, just kidding. All right, last problem that I want to talk about is the problem that we started with, which was this one, okay? Your parents tell you that this is just the sum of a geometric series, right? It's not converging. It goes on forever and ever. So this can be modeled by the formula a sub n is equal to, what's the first term? If they give you a penny on the first day. 1. What's my multiplier? 2. Okay. Raised to the n minus 1? N minus 1 or raised to the n? 1 times 2 raised to the n minus 1. Right? Okay? You get that? Does everyone see why? Because you start with a penny. On the first day, first day, this is going to be a 0, right? What's 2 to the 0? 1. So this formula is going to give you 1 on the first day, right? It's going to give you 2 on the second day. It's going to give you 3 on the, no it's not. It's going to give you 4 on the third day. It's going to give you 8 cents, okay? So if I want A on the 31st day, that's going to look like 1 times 2 to the 31st. But I want the sum, right? So the S sub 31 is going to look like A sub 1, which is 1, times 1 minus, what's R? 2 raised to the 30th power. 30th power? 31st power. No, the formula is 1.
It's just n.
Yeah, it's just n in the formula. Okay? So in the formula, this number is 31. Okay? That whole thing over 1 minus r, which is 2. So what's 1 minus 2? Negative 1. So I'm going to rewrite this as negative 1 times, because negative 1 could be on the bottom or the top, it doesn't matter, times 1 minus 2 to the 31st power. Do you guys see what I just did? Okay, negative 1 divided by 1 is negative 1. So I just move that up top. Now I'm going to distribute through this negative sign. So I get this is equal to 2 to the 31st power minus 1. Right? What's 2 to the 31st power? Anyone got a calculator?
2, 1, 4, 7, 4, 8, 3, 6, 4, 8.
2, 1, 4, wait, 7, 4, 8, 3, 6, 4, 8. But you do have to subtract this 1, right? So you lose a cent somewhere there, right? So that actually comes out to be a 7. And these are only pennies, so it's not really that much, right?
Wait, why do you?
Because over here, minus 1. 2 to the 31st minus 1.
Okay.
Okay? So, is it still a lot? Where does my desk? Oh, now we got dollars, right? Now we got dollars. So let's go this way. Let's go this way. So, yeah, you tell your parents that you'll do all this stuff, okay? Because if at the end of the month, they'll owe you $21 million and change. You're getting bankrupt to your parents.
21 and a half.
Yeah, after the first week, they'd be like, oh, wait, this is okay, I could do this. And then maybe the second week, they'd be getting a little nervous. By the third week, they'd have to cash out your college fund. Okay? And then the fourth week, they'd be bankrupt. Or, never mind. Okay, so that's pretty good coin, right? You should do that. How many think your parents would get that? Your parents would figure it out. But you should try that at home. And don't tell your parents I said that.